So when we looked at the nervous system, the important concept is to realize that we normally have what is known as a stimulus, and a stimulus is normally detected by a receptor, and these receptor cells, what they do is they're going to transmit an impulse via the sensory neuron to the spine and the brain, which is your central nervous system. And when the information is interpreted in the brain, it is therefore going to be part of the response. Then the brain will send an impulse via the spine and through the motor neuron, which is of course both interconnected by an interneuron, and to the effector. The effector could be a muscle. So this was the basic concept of the nervous system and how it operates. However, now when we are dealing with what is known as a endocrine system, a few things are going to change here. Remember, you are responding to the external environment when you are dealing with a nervous system. Now you'll be responding to the internal environment, and therefore the stimulus will still be there as well as receptors, but now we will more so be looking at one important aspect here, which is a hormone instead of an impulse. Remember, here we had what? You had an impulse that is transmitted by receptors. Receptors, they convert stimulus to impulse, and then this impulse is going to be transmitted to the spine, brain, back to the spine and the effector, right? But now all that will change. How so? This is what will happen. This is what is going to happen. Now, instead of having an impulse, right, we are going to have the blood. The blood will not the blood. We are going to have a hormone. So a stimulus will be picked up, and a hormone will therefore be secreted, and then a receptor will now be replaced by what is known as this receptor is going to be replaced by an endocrine gland that picks up a stimulus, and I will explain what I mean by that. So this will be replaced by an endocrine gland, So an endocrine gland is the one that secretes a hormone, and this hormone now it will travel via the blood. So the spine and the brain are no longer part of this pathway. So now we are going to have the blood that is transporting this hormone where it should be. So we are going to have the blood here. So the hormone will therefore be transported to the blood after being secreted by the endocrine gland, and now the blood will take the hormone. Instead of having an effector, now the effector is going to be replaced by what is known as a target organ. We're going to have a target organ, so the motor neuron as well will no longer be taking part in the pathway. So this is going to be our new pathway now, whereby we are going to have a target organ. This is your target organ. So there are three things that are very important here. Now, talking about the stimulus will just be an increase or a decrease of a certain hormone, and in that case it will act as a stimulus, and that will be picked up by certain receptors will still be there in some instances, and those receptor cells, as they pick up this decrease or increase, remember now, we are trying to maintain a balance in the body. So as they pick up this increase or decrease, then they will alert the endocrine gland, and the endocrine gland will therefore secrete a hormone, and this hormone will therefore be secreted directly to the blood, and the blood will transport the hormone to the target organ, right? So it's not always the case whereby the endocrine gland secretes a hormone directly to the blood, but now that is the difference between an endocrine as well as the exocrine gland. The endocrine gland secretes a hormone directly to the blood, whilst the exocrine gland, it secretes a hormone into a duct or an organ. And in this case, an example for that would be a sweat gland. Sweat glands, what they do is they secrete sweat through ducts, or sweat duct, and the sweat will move through to the skin, which is an organ. So you must understand the difference between an endocrine as well as an exocrine gland, being that they secrete their hormones in different places. Endocrine secreting in the blood, exocrine secreting in the duct or the organ there. Now, defining a hormone, you can simply say that a hormone is a chemical messenger. These are chemical messengers secreted by the endocrine, and so they're secreted directly into the blood and transported to the target organ. But the simplest way to remember it is by saying that this is your chemical messenger. Now there are a few locations of each of the glands. These endocrine glands, you must know them. They are very much important. Number one being the hypothalamus. Then you have the pituitary gland, or you can refer to it as the hypophysis. But be careful, don't mix up hypothalamus and hypophysis. Those are two different endocrines. So the endocrine gland, so don't mix them up. Pituitary gland or hypophysis, then you have the hypothalamus, then you also have the thyroid gland as well as the pancreas. I'll talk more about that. Adrenal glands, the ovaries as well as the testes are also the endocrine glands, which you learned about in when you were doing reproduction, or the reproduction in humans. So you are going to do it again, you'll just have to recall some of the information from there. I'll be moving on to the endocrine glands and their location in the human body, which is also important. You must be able to recall this information.